Since we have seen data manipulation language earlier, right? We have seen delete, update, insert, select, all of these. The next subset of commands in SQL is called DDL, or data definition language, right? So this is also called as DDL, right? So let's look at some of so data definition language, as the name suggests, helps us define tables or modify tables or alter tables or completely let's see as we go, right? So the first thing is, of course, the create command here. The create table helps you create a table. I'll show you a simple example and I'll explain what each of these mean in a short while, right? So create table, the table name that we want to create, the column name, right? Look at our data set, right? We have the movie data set from IMDb. Imagine if I want to create a new table, let's call this table as language, right? Where each movie's ID will be present and the language in which this movie is also present. There could be some movies which are in Hindi, some movies in English, some movies in Spanish, some movies in French, etc., etc., etc. Right? So this is also a very interesting piece of information, right? This table currently does not exist in the database that we have, right? So it makes complete sense to create a new table called language, right? Which has an ID, right? This will be the movie ID. Lang here basically means the language that the movie is in. So there are a couple of interesting things here. Okay, let me explain what they are, right? So if you look here, it says ID int. What this means is it says ID is of data type int, or it's an integer value. Okay, so this is telling me the data type here. Similarly, lang is saying varchar 50. So varchar basically means, varchar 50 basically means it's a character string. It's a character of max length 50. It's a character of max, it's basically a sequence of characters. It is a variable length sequence of characters with a maximum length of 50. This is one way you store strings in SQL. We'll look at other data types also, right? So varchar 50 basically means that it's a sequence of characters of variable length with a maximum length of 50. Okay, so we'll look at more data types and understand the data types in a little while. But as far as this SQL statement is concerned, ID belongs to the integer type and lang belongs to a character sequence or a varchar type, which is nothing but a string with a maximum length of 50. Okay, so that's one. So these are called data types. This is a data type, this is a data type. The other important thing are called constraints, right? This is a constraint. Similarly, this is a constraint. A constraint here basically means, says some properties about this column. So the very fact that we said primary here means that this is a primary key for this table language, right? And what is a primary key? A primary key can never be null and it has to be unique for each row. Similarly, when I say varchar 50 not null, this is also a constraint on this column. See, this is a constraint on this column, this is a constraint on the lang column. What we are saying here is this cell can never be null. So if I try to insert into this table with either a duplicate ID or with a language that is null, it will not accept it. It will throw me an error, because when I'm creating the table here, I'm clearly stating that the ID is primary key and the lang can never be null. Because here, look at it, here I'm literally stating what the table should be like, right? So if I try to insert something where there is a duplicate primary key or a null value for lang, it will not accept it, will throw an error, right? So this is a very simple create table command. Now to understand data types, as we have always done, let's use a very nice diagram that I've found, right, on this web page. Again, this is in our learn to learn. We should always Google search. What I did here is I said SQL data types. Okay, I'll show you what I exactly did so that it's easier for you, right? So I literally said SQL data types. I got this and I got this nice image. right? This image, one image can tell us a lot more stuff. The SQL data types can be numeric. Numerics can be bits, tiny bits, small integers, int, this is what we were using. Big integers to store larger integers, decimal, numeric, float, and real value. Similarly, there is character or string, for which we can use char or varchar or text. Again, some SQL databases might facilitate only some of these data types, not all. Varchar is very popular. It's supported by almost all the databases. Int is also supported by all the databases. Date time, right? There is a data type called date where you can store date. There is a data type called time in which you can just store the time. There is something called date time where you can store date along with time. Okay, there's something called as timestamp, which stores the Unix timestamps. Okay, very popular in the Unix community, right? Similarly, you can store, so this is regular strings. If you want to store strings in non-English languages, there is something called as a Unicode encoding of characters, which has strings from many, many languages and special symbols and stuff like that, right? So you have nvarchar and nchar, ntext to represent data which is in Unicode character formats. Similarly, binary data, which could be image data or a binary file, whatever you have, right? You can store it here. And special purpose data like XML, JSON, right? These all are data storage formats, very popular formats. Okay, there is something called as blob files, right? So JSON and XML are very popular in the internet community because XML and JSON are extremely widely used to store data, also to transmit data for internet databases. Right? So all these are popular SQL databases. Again, not every database may support every data type. Some of these are supported by some databases, some of them not supported by other databases. But it's important to have an idea of what is possible. Similarly, so this is the reference link here. I just Google searched, I said SQL data types, and I got this very nice diagram. Similarly, for constraints, I again Google searched. It's very, very important for us to learn. Your learning should not end here. Your learning should only start here. Okay, and there is no better library in the world that I know of than the internet itself. So if you know how to Google search well, how to learn from the internet, and if you're constantly learning throughout your life, nobody can compete with you. You're almost invincible, right? And of course, if you work hard, there is no replacement to that. Okay, having said that, let's look at some constraints, right? So we have a constraint called not null that we used here, right? What it says here is that this column that we're using here cannot have null values. Similarly, I can have values like unique. Unique means that all the column values are different, but unique can contain null values, right? So unique does not necessarily mean not null. All that it says is all the values in the column are different. Similarly, there is something called as a primary key that we used here, right? Primary. Okay. A primary key is something which is not null and which is unique for every row, and it uniquely identifies each row. Okay. So these descriptions I've taken from this web page. That's why I'm referring it here, right? Foreign key, right? A foreign key basically means that whatever you have in this table needs to be present in the other table also, right? So for example, the ID here, the movie ID here, we have not added it here. Ideally, it should be a foreign key. This should be a foreign key to the movie table also, to the movies table also. We need to add that also here. Okay, but I didn't want to confuse you with a very, very complex create table statement here. If you are actually designing this new table called language, you should add this foreign key constraint also, right? The other thing is called check. Check basically ensures that a column satisfies a specific condition. For example, I could always create a check condition saying for example, I have a salary database. Okay, I should always ensure that the salary that is mentioned there is greater than equal to some minimum threshold. Obviously, certainly greater than 0, right? Similarly, there is something called as a default value. When I'm inserting anything to a table, if no value is given, there should be some default value. For example, in this language database, if I'm not clearly giving the value of the language, if I don't explicitly say anything, the default value should be English, because IMDb contains mostly English language movies, right? Then there is another keyword called index, very, very important. So the moment you say index for any of these columns, the database the database internally indexes when it creates this table, right? It creates an index on this column. So whenever you create an index, you can retrieve data much more efficiently. You can perform joins much more efficiently. Again, indexing is a full-fledged subject in an undergraduate level databases courses. There are many strategies for indexing, from advanced data structures, hashing, you name it, right? There's something called as a B plus tree based indexing. There is a hash based indexing. That's a big area in itself that we need not go into as far as SQL is concerned, right? But it's something that we will learn in an undergraduate level computer science or a database course, right? So indexing in a nutshell helps you retrieve data faster. It helps you also make some of the database operations like joins very fast, right? So when you're creating a table, for every column you create, you mention the data types and you mention the constraints that each of these columns should satisfy. That's what is create table in a nutshell.